All right, this is my Advent of Code 2024 solution for day one, parts 1 and 2. It's tacit and unreadable, but it's a BQN, and that's normal as far as I know. So I'm going to go ahead and try to break it down for myself, because I wrote it like, 12 hours ago, and I can't remember how I wrote it. But hopefully, because just, 25 lines, give or take, logging and output and stuff, that I can break it down in a few minutes for myself in the future. So this is the first thing I'm doing, where I'm reading in the files, the file line by line from this exact file. I'm pretty sure I have to go relative to the path rather than the working directory. I'm not clear on why, but that's fine. I know there's I was watching a code report doing it, and there's like a WD path or something. Oh, look at that autocomplete. That would show me the working directory, I guess. But anyway, that'll be cool. So now, then I also mark down number of the number length. So if I open my sample, sample, there you are. We can just see the numbers is one length or whatever. Whereas if I do inputs, it should be 5 inputs. There you go. They're 5, which is nice. So I hard coded that. In the old version, if I have this one, I had the I do have, I should say, the inputs and their own num length defined. I'm using this character to redefine the character, which means change, whereas this one just means assign or define. There you are. So let's go back to where I was. So then here I'm defining a log function, which takes 2 arguments. The left argument, which I'm naming instead of w, by default. I don't think I use x and y, but by default I'm calling it instead of w, I'm calling it message, and then the right of it I'm calling val, which I just literally just print line. Basically I show both values, and then I return val, which lets me log things. So I say left log right, and then I can actually say val, and if I just do show val, I'll have the log message and the value, and then I still have the value after, which is cool. All right, and again, I only use it at this point in the bottom, but that's fine. So I first have a parse function, which takes the raw lines. Actually, I can just, can I rename it? Ooh, yeah, the new BQN LSP has been upgraded, and it's wonderful. This is the same, obviously, but I could, if I really was I don't know, dedicated, I could just remove the name of it and just dedicate, or not dedicate, I could use or rely on the right argument value. But I think for legibility, I like having names. Unfortunately, you can't do that in BQN, but that's totally fine. Then I have a function parse float. I don't know if I can look at the docs. This just literally parses a float, so it takes the string the character 4 and turns it into the number 4. Excellent. So this is a train here, this bad boy. This is okay, this is a single function. Ignoring the yellow thing, this is a function that does 3 things. At first, it's a left train here, where we have our this thing, our right tine, I learned it's called, and then I go over here, and this is the left tine. And both tines, like of a fork kind of thing, I guess it's officially salt, is a F1, F3, F2, and I call it lines. Actually, a single line, because we'll get that in a second. So this is actually turns into, and I'm going to go over this because I always mess it up, single lines, and then F3, F2 single lines. So it calls, again, F2 and F1 on the individual value, and then calls the result of that on both. So sort of like how log took 2 values or whatever, this F3 will take 2 values. So this function gets run on 1 value, is what I mean, and this one too. Then the result of that gets passed on this. Hope that makes sense. I'll leave it up here for a second. So this guy, that's the right tine, does this bit here where it says not prefix, because that's the 1 argument version. I'm using the 2 argument version, which is take, which takes a number and a array, I guess. And then for each number in the array, take that many elements for the dimension. Oh, hold on. Can I do something? Nums log. I do, hold on, the range of 10, right? Nums, okay, good. And I do take. We'll get there. Take 3, right? I take 3 of them. What if I do 2 numbers here? Well, what is that doing? I don't understand what that's doing. Can I do again one? Hold on. Maybe that's just the dimensions it returns. Not sure. Okay, I'm gonna ignore that for now. Anyway, so we take this number negative. So we have 1. So take -1 from the list, and our lines, our raw line here, you'll see is I could just do log. We'll do raw line log lines, but I'll do first lines. So raw line. Okay, I'll do the first element here, which you'll see is the first element of this, which raw line is just the string. So what this is doing is it's getting the last character from this. So I'll do this. Right, well, that works. Yeah, perfect. So the last character, -1 characters, is 4, and then I pf it, which is to say I parse float it. So you'll parse float. I can parse float, just make it explicit, and it turns into a 4 instead of a string 4. It's an actual 4. Nice. So that's my left one, or my right one. My left one is the same thing, but instead of negative, it's just this, which is just the first character, because you'll remember, well, not raw line anymore, but you get it. Bad namings, parse line or something. So the raw line is this. Wait, shoot. We got to go our first element first. I forgot about that. So our raw line is this. The left one is this very left number. If I wanted like the middle one, I could just do, I could do 2, which is going to be a space, but it's going to complain that this is not a real thing anymore. So I take the last 2 characters from the back. From the back. There you are. So space and 4, like in Python, and this would be the first 2 characters, 3 in space. Hopefully we're on board. So then now we have the 3 character in here, or the digit, sorry, 4, and we have here the digit 3. So again, this turns into 3 and 4, I think I said. And F3 here is our couple pair. Oops, FG, FG. There you are. Pair. There we are. It takes 2 things. For us, it's 3 and 4, and then turns it into a list. So let's. Well, actually, I could just demo this. We got log. I'm gonna do 3 in list 4. Look at that. So now we just have, it's basically, it's just literally a list. So if I do this, thanks LSP, we got this, and this is the same thing, which is just like an element of okay, begin list. Well, we'll see for more details here. Starts a list, and the list is some sort of one-dimensional array. I don't fully get it, but that's cool. Excellent. So now our nums, and I should clarify as well that this each function here does that for each element. So the trick I was doing before was that this lines example had to get the first element of every thing, but this each one does that for me. So instead of having to do raw line 1, raw line the first element, then the second element, etc., I can just loop over all my things with just each function. So then now it joins up in a list. So I can now do nums, I guess. Here we are. So you can see all my nums in a nice pair. Because we know, again, our sample function is 3, 4, 4, 3, etc. Cool, we're parsed. We're parsing easily. And that's again, that's a train that is making that easy. Without the train, it would be a little more liney, let's say. Then for part 1, which again, part 1, if you'll recall, is can I go back to part 1? It's taking these 2 lists, individual lists, so all 3, 4, 2, 1 is one list, and 4, 3, 3, 5 is the right list. Then I have to sort them, and then pair them up again. So that's pretty easy here. You can see here where this is. So remember how after we're parsed, this is actually nums, right? At this point in time, we have nums parsed in. Then we join them all together. So from all our nums, I'll just show them just to keep it maybe simple. I have this thing, then I flatten them. This should still work. So it should become now 3, 4, 4, 3. 3, 4, 4, 3. Excellent. So this turns into this. They're all joined together. Then I'm going to now reshape them into a 2-dimensional or something array that does something with it. It ensures that X number of rows, but there's always 2 columns, I think, is how to think of that. So let's, again, fact check that. Excellent. So now we're sort of this, and we went to this now. This I guess I should say, this is a reshape. So I'm giving it the shape, and then the array that I'm sorting, and this says the exact fit. So the dimension, don't know how to read that, but the idea is like I said, unknown amount of columns, rows, unknown amount of rows, but at least 2 columns. Yeah. So if y is the first dimension, x is the second one. Again, I don't know if that's helpful or not. Then we go into this beast of a train again. Again, the F1, F2, F3 thing. So now we're getting a little fancier, where we're saying this. Oh, can I even get this? This is our left. It should be. Oh. No. I apologize. This should be exactly the same. Excellent. Very easy to read. This is exactly the same. So our left tine, our left tine is this guy here, and then our right tine is this. So because we're operating over all the rows, the pairs here, the first thing is we're going to take the first element of each individual row, because remember how the each up here is the each whatever. This is now the cells, which I think is basically the top element of each. So if each hits 3 4 4 3, cells will get 3 4 and then 4 3 and then 2 5 individually, or not individually. When I get the second one, which is the 1th one, which is say 4 3 5 3, then I'm sorting this in a list. So it goes, right now the order is 4 3 5. If I sort it, it'd go 3 4 5. And then likewise with the other element, it's instead of doing the first element or the 0th element, whatever. Instead of the 1th element, now I'm getting the 0th element, which is the same thing. Well, here the same thing. And then I'm joining them together. So I'm basically repacking this into a flat list. Let me see if I can show it here. There we are. Oh, that's excellent. So it's just sorted now because 1 is the lowest, 4 is the highest. So 1 is the lowest and 4 is the highest. And then in here, 3 is the lowest, right? Yeah. And then 9 is clearly the longest, so we can tell it's sorted. Then once again, we're deshaping it and reshaping it into pairs. Do I need to actually? Now that I'm looking, I don't actually. That's cool. So I can get rid of this. This is now we're back to where I just optimized my solution here. Excellent. Shows you what revisiting can do. Now our sorted nums is just these pairs, and this is where we get a little fancy again. This is all one big function, where we're going for each pair of these. We're gonna reduce, which are fold between, but reduce this other function. But the fold maybe is easy to think of it as like you put the character in between. So 1 plus 2 is 3, and then 3 plus 3 is 6. That's well, there you go, right there. Excellent. And then again, we're gonna fold. We're gonna put this function in between each one of those elements instead of plus. And this is the swap character. So it swaps x and y. So you put x and y or x and w instead of here you go. So this is how you call it, and then it actually calls this. And then if we compose it, which we combine or whatever, we call G first, and then we call F on the result. I don't know how to put that into words any better than that, I guess, for now, but I'm sure eventually I will. And then I combine it with the absolute value. So let's say the trick I had trouble with was like 3 minus 1 is 2, but in the real example, there'd be like a 900 on one side and like a 1000 on the left. So it was a negative number, and I would get caught up on that. So then that's now giving me the differences between each one. Let's show them. So there's a difference of 2 here, a difference of 1 here, a difference of 0, etc. And then I'm just summing it up. So 2 plus 1, and I'll show it again. Summing it up with this, right? So this is folding it. I'm doing a plus between every one of these guys. And that gives me 11 for the sample. Hopefully that making sense. And that gives me this. So that's cool. I can now get rid of all our showing. And hopefully we'll actually, can I just show this? Go next. X. There we are. Excellent. If I had a formatter, I could reformat that, but for now it's fine. Now, part 2 is the same idea, where I have nums, which is the same as before. Just the parse pairs. So the right numbers now, instead of both left and right numbers for now, we're just going to take the right on. So 4, 3, 5, whatever. That's what right nums is. So again, 435, 435. We're gonna click over here. So what does that give us? So now this is actually the left numbers of this, which I can again show. There's probably a better way of doing this now that I'm looking at it, but this is the left argument, and these are the right. So you can kind of see if you twist your head, 3 4 is the first element, 4 3 is the second, etc. Then this curly brace thing is like a block, a local function or a scope almost, where for each left number, which is the second thing. So for each one of these, I compare it to the entire list of the right nums. So if I do, I'm going to take only the mess our numbers up a little bit. I'm going to take our first number, which is 3, and then now just call this number on its own. We don't care about this for now. We're not gonna sum. What's our log? This is what we need our log. Okay, this is our input here. Input log. We can see inputs 3. So if we're gonna have each one of the right inputs, so these guys are right inputs, I believe. If 3 equals any of them, it'll be a 1. So let's see how we're doing. Let's call it mask log. So if any of these numbers are 3, we'll get a 1, which we can find here. This is a 1, this is a 3, which is our 1 here, and this last one and this guy is also 3 and 1s. So then we're just summing up here all the 1s. So we're putting in 0 plus 1 plus 0 plus 1 plus 1 plus 1 is 3. Then we're multiplying that because the part 2 is just saying fine. I don't know where it says it, but it says somewhere. Oh, part 2, there you go, perfect. It's saying take the number of times it occurs times the actual number. So we're looking for 3s. So 3 times 3 occurs 3 times, 9, etc. 4 occurs 1 time. 4 occurs 1 time, and then so that's what the multiplication is. And then from there we're just plussing it, I think, right? I don't remember what it was, but that's what we're at here. Let's get rid of our log. Delete find gust. Nope. No, I broke it. Oh, because I don't have to do this anymore. And then we're eaching. Perfect. And it's 31. So 4 plus 3 plus 5 plus 9 plus 3 is 31. Excellent. Hey, pretty easy. I don't know if I could have read that without going through it, printing it off, but there we are. Hope you enjoyed. I'll be doing number 2 again tonight. See you guys soon.